Okay, welcome to another video. Today's topic is a representation of data. For the sake of convenience, I've divided representation of data into two parts. So I'll be solving a range of questions today, and then you will see another video where I solve another range of questions which will involve quartiles and everything else. Today's class is more about mean, standard deviation, and all those things. So let's begin. The following table shows the results of a survey to find the average daily time in minutes that a group of school children spent in internet chat rooms. The mean time was calculated to be 27.5 minutes. Form an equation involving f and hence show that the total number of children in the survey was 26. Okay, so I need to use this mean. To calculate mean, I need the midpoints. The midpoint is 5, and then 15, and then 30, and then 40 and 80 have a midpoint of 60. So to find the mean, I have to do sum of fx over sum of f. So that gives me 5 into 2 plus 15 into f plus 30 into 11 plus 16 to 4 divided by 2 plus f plus 11 plus 4. This should equal 27.5. So let's do that. That's 10, 15f, 330, and 240. And I have 17 plus f. So 27.5 into 17 gives me 467.5 plus f, 330 plus 240 plus 10 gives me 580 plus 15f. And then I have it has to be a mistake somewhere, and it's 70, that's 27.5f. Okay, so 580 minus 467.5, that gives me 112.5, and that gives me, I think, 12.5f, and f should therefore be 9. So the total number should be 2 plus 9 plus 11 plus 4, which should give you 26 as the total. That's what the question was asking you to show. Okay, so then I have find the standard deviation of these times. So you use the standard deviation formula. I already have the mean, so I can say that the variance will be sum of x squared f over sum of f minus the mean squared. So x squared, the midpoint is my x, so plus 15 squared into 9 plus 30 squared into 11 plus 60 squared into 4 divided by 26 minus 27.5 squared. And then I take a root of all of this. Now I can do most of these calculations on my calculator. I don't need to show you all the calculations. Yet it's important to first write down what you are trying to calculate because you may make a silly mistake. Okay, so this is going out to be, okay, that's what my calculator turned out. I haven't calculated anything individually. So 16.1 is my final answer. That was question number one. Question number two is about coding of data. Let's talk about that. The length of time in minutes to do the crossword in a certain newspaper was observed on 12 occasions. The results summarized below. Calculate the mean and standard deviation of these times. So I'm asking you to do the mean of t and the standard deviation of t. Now, from my rules, I already know that the mean of t minus 35 is the same as mean of t minus 35 separately. Now, how do I calculate the mean of t minus 35? I use the sum of t minus 35 and divide it by n. I need the mean of t, so I'm just going to write t bar minus 35. What is the mean of t minus 35? I've given you that as minus 15. So t bar minus 35. So t bar is equals to 35 minus 15 over 12. 33.75. I know that the standard deviation is equal, so variance of t minus 35 should be the same as variance of t. Once I have the variance of t, I'll be able to find the standard deviation of t. How do I calculate the variance of t minus 35? I'm going to say that t minus 35 squared, the sum of t minus 35 squared minus the mean of t minus 35. So that is the mean of t minus 35, and that's whole squared. So it's the same variance formula. It's just that instead of using t itself, I've used variance of t. So variance of t. So I get 82.23. That's 2.3. Okay. Then question number 3 is interesting. It says the computer can generate random numbers with either 0 or 2. On a particular occasion, generates a set of numbers which consist of 23 zeros. So can I say that if x was 0, its frequency was 23, and there's 17 twos. Find the mean and variance of the set of 40 numbers. I think that's simple then. Mean is just fx over f. So 0 into 23 plus 2 into 17 divided by 40. 0.85 standard deviation. Variance. Sorry, this question is asking about variance. So that's sum of x squared over f over n minus the mean squared. The mean is already there. So 0 squared into 23. Okay. Moving on to question 4, it says the age x years of 18 people attending an event. Evening class are summarized by the following tables. Okay, 18 people. Calculate the mean and standard deviation. That's simple. So mean is just 745 divided by 18. 745 divided by 18, 41.4. 38, let's say 39 and then 41.4. And then standard deviation is, I have a feeling the answers given here are wrong. So let's just being safe there. Then gives me 13.2. Yeah. Then part 2 says one person leaves the group and the mean age of the remaining 17 people is exactly 41 years. Find the age of the person who left and the standard deviation of the ages of the remaining 17 people. Okay. Okay, so one person leaves the group, so I have a total of 17 now, and his age was exactly 41 years. So this sum must have changed. So the new sum would be sum of x equals to 745 minus 41. And the sum of x squared should be what? It should be 33951 minus 41 squared. I'm removing one of the values from the data set. Find the age of the person. Oh, no, sorry, my bad. I didn't read it correctly. One person leaves the group and the mean age is now, sorry. Okay. So I want to find that age of the person who left and the standard deviation of the ages of the remaining 17 people. Okay, so that's also fine. So x bar is now 41. So I know that 41 is basically the sum of x, which is new. Okay, let's write new divided by 17 in this case. Okay, so 41 into 17. 697. So whoever left reduced the sum. Okay, so what is the new sum? It's 697. The old sum was 745. So this person was 48 years of age. Okay, that is what I know from the mean. Then I want to find the standard deviation of the remaining 17 people. So what I can say is that this sum would also be adjusted by 48 squared. Sum of x squared would no longer be 33951. It would be 33951 minus 48 squared. So standard deviation equals to 33951 minus 48 squared divided by 17 minus the mean of these people, which is 41 squared. And I can put this entire thing in a root because I want to calculate standard deviation. So 33951 minus 48 squared divided by 17 minus 41 squared, and the root of answer is 13.438, which gives me 13.4. Okay. In question number 5, a group of 10 married couples and 3 single men found that the mean age XW of the 10 women was 41.2 years and the standard deviation of the women's ages was 15.1 years. For the 13 men, the mean age was this and the standard deviation. So I am giving you women data separately and men's data separately. Find the mean age of the whole group of 23 people. Now remember that whenever you're trying to do the whole, as we've talked about this before, you cannot simply just add the two categories together, two means together. You need to add the components of the two categories together, which means that you need to add the sums together, you need to add the ends together, and then come up with new sums and new ends to find the mean of the entire group or the standard deviation of the entire group for that matter. Okay, so let's try doing that. I have 10 women and their mean is W bar, and that's 41.2, and the standard deviation of this is 15.1. There are 13 men, their mean is 46.3, and the standard deviation of men is 12.7. Okay, mean age of the whole group. So what I'm going to do is I'm going to first take the mean age of the women and say that I want to find the sum of W. So what was the sum of the ages of the women? So I find that out, and that's 412. What about the men? 46.3, sum of m divided by 13. 13 into 46.3 gives me 601.9. Okay, so then I have the total sum, 412 plus 601.9. It gives me what? 1013.9. So the new, so the mean of the whole group is simply 1013.9, divided by 23. 44.0, which is 44.1 through correct to three significant figures. Okay. Then part 2 says the individual women's ages are denoted by XW and the individual men's ages are denoted by XM. By first finding sum of x squared w and sum of x squared m, find the standard deviation for the whole group. So I'm going to do that as I did for the mean. I am going to decompose the standard deviation now. Now remember that I can't decompose the standard deviation. I'm going to use the variance. So I'm going to use 15.1 squared, and I'm going to say that this was equals to sum of x w squared divided by 10 women, and the mean ages of those 10 women was 41.2. So I've applied the variance formula, and let's see if I get the correct answer. So I'm just going to square and add up quickly. So 15.1 squared plus 41.2 squared, that gives me 38509 over 20 equals to sum of xw squared. I just added, subtracted, multiplied by 10, and this gives me 19254.5 sum of xw squared. Can I do the same for the men? I can say that 12.7 squared is sum of xm squared divided by 13 minus 12.7. Oh, sorry, minus 46.3 squared. Let's quickly add that up. I am getting 29964.7. Okay, I found the individual sums. Let's combine them to find the combined variance and then the combined standard deviation as well. So I'm going to say 19254.5 plus 29964.7 divided by 23. What is the combined mean? What did you find as a combined mean? You found 44.08. So 44.08 squared. Okay, so I'm getting 196.92. I'll take a root. That gives me 14.033. Yeah, 14.0 is your correct answer for standard deviation. Okay, I hope this question was useful. Let's look at this. This again looks like coding of data, so let's talk about that quickly. It says, Esme noted the test marks x of 16 people in a class. She found that sum of x is this, and the standard deviation of x was 6.5. And that I usually don't use the standard deviation, so let's keep that as the variance. Okay, calculate sum of x minus 50. Now that's weird, but let's just stick to our guns and say that sum of x minus 50 is the same as mean of x minus 50. Okay, so mean of x minus 50 is the same as mean of x minus 50. In order to find mean of x minus 50, I'm going to say this. And do I have the mean of x? No, I don't have the mean of x, but I have the sum of x. So I'm going to write sum of x divided by this. So 824 divided by 16 minus 50. Sum of x minus 50 over 16. I think that's solvable. I can just cross multiply once I've added, subtracted on the other side, and say that this is going to be sum of x minus 50 is going to be 24. I think I've used the same formula, same concept. I have changed nothing in this regard. So you should be able to get an answer out of this. Sum of x minus 50 whole squared. So I'm now going to use the variance. I'm going to say that 6.5, variance of x minus 50 is the same as variance of x. Coding doesn't change the variance or the standard deviation. So in order to break this down, I can say the sum of x minus 50 squared divided by 16 minus 24 over 16, which is the sum of x minus 50. I'm subtracting the mean of x minus 50. And the variance of x was 6.5 squared. So that makes it easy. I can just take it to the other side, add it up. 24 over 16 gets added on the other side. 24 divided by 16 squared. So sum of x minus 50 whole squared over 16 equals to 89 over 2 multiplied by 16. So that's 712. Are both my answers correct? Yes, both my answers seem correct. There's this one person did the test later and her mark was 72. So the sums should have changed. So this should have become 72 plus 72. And I don't know the sum of x squared. Calculate the new mean and standard deviation of all 17 people. Okay, so I can calculate the new mean very quickly. I can say that this is just 824 plus 72 over 17. I'm getting 52.70588, which is essentially 52.7. And I'm going to keep it at that. Yes, that's the correct answer. Now for the standard deviation, it's a little tricky because I like sum of x, I don't have sum of x squared. Now there are two ways of doing it. I'm going to tell you both ways. One of them is easier to understand, the other is quicker to do. So let's just see what we can manage. Now, can I use this variance to decompose it first? Can I say that this was actually sum of x squared divided by 16 minus the mean squared, which was 824 divided by 16? Okay, so in that case, I can find out what the sum of x squared was before this new student gave her test. So multiplied by 16, 43112. Okay, so 43112, sum of x squared. Okay, then new standard deviation would be 43112 plus this new person got 72, 17 minus the new mean. What would be the new mean? Did I just find that out? Yes. So 43112 plus 72 squared divided by 17 minus 52.70588 squared. I'm getting 63. Oh, I didn't put a root. Put a root. 7.93. 94. 939. Yeah, that is the correct answer. Let's go on to question number 7. Now this might be a little tricky. Please look at it carefully. Let's see what we have later on. We have one histogram, and then I think, yeah, a couple of more questions. Let's do them. It says 32 teams enter a knockout competition in which each match results in one team winning and the other team losing. After each match, the winning team goes on to the next round and the losing team takes no further part in the competition. Thus, 16 teams play in the second round, 8 teams play in the third round, and so on until 2 teams play in the final round. How many teams play in only one match? So the ones who play in only one match will be those who get knocked out in the first round. So 16 of these teams that were in the first round, so 16 were competing against 16. So 16 of them get knocked out and don't play any other matches, if you just play one match. Okay. How many teams play in exactly 2 matches? So those that got knocked out after the second round, and how many teams would those be? If 16 got knocked out in the first round and 16 went into the second round, that means there were 8 matches, so 8 teams get knocked out again. So 8. Okay, draw up a frequency table. Okay, so I can say that no teams played 0 matches. Okay, so some teams played only 1 match, and that was 16. Some teams played exactly 2 matches, and those were 8. In the next round, some teams would play 4 matches. Those were the quarterfinals. And then some teams would play 2 matches. Those were the those were the teams that reached up to the semi-final but lost in the semi-final. And 5 matches would also be 2 teams, because both teams that reach the final round will play the final match and will also play the first 4 rounds. So they've played all the rounds, therefore they've played a total of 5 matches, including the final match. So that is what your table should look like. It can't do 5 and 6, because there's no team that plays 6 matches once you win the tournament ends. Okay, calculate the mean and variance of the number of matches which the team plays. Okay, so XF mean is easy then. It's 1 into 16 plus 2 into 8 plus 3 into 4 plus 4 into 2 plus 5 into 2 divided by 32, I think. You can also see that the total should also add up 16 plus 8 plus 4 plus 2 plus 2. Yeah, 32. $1.9375. That rounds off to 1.94. Variance. Minus mean squared. My bad. Okay. Moving on to the next, this is again coding of data, sample of 36 data values, which gives this and that. Find the mean and standard deviation of the 36 values. Okay, so mean of x minus 45 is the same as mean of x minus 45 that side. So I get minus 148. So I'm going to write the sum of x minus 45 here divided by 36. Sum of x, mean of x is what I want to find. This is right, x bar. So minus 148 over 36. Okay, that's one. Variance of x minus 45. So I get 3089 over 36 minus 148 over 36 squared, and that gives me the variance of x. Okay, standard deviation should therefore be 8.330. One extra data value of 29 was added to the sample. Find the standard deviation of all 37 data values. Now, in the previous question also, I forgot to tell you the other way. Now, you see this data is compiled for x minus 45. So what you can do is, if you are adding a new value to it, instead of adding 29 to this, what you add is 29 minus 45. Let's see what happens. So minus 148 minus plus 29 minus 45, and that gives me minus 164. So I could use this and sort of compute a new standard deviation instead of going around all of sum of x and sum of x squared, and I could come up with a final answer actually. Okay, let's do it that way. There is another way to do it as well. What you could do is you could, pick this up, decompose it, find the sum of x first, and then change that sum of x by adding 29 to it, and then finding the new mean. Then you could pick up this variance, work backwards, find sum of x squared. Now you can write 68.9 equals to sum of x squared over, in that case, how many? 36 data values. And then I could, sort of take this mean and say 40.9 here, and I could find this new sum of x squared. I could do all of that, but I could also do what I'm just telling you, that I could take this and change this. So the new sum of x minus, so I'm going to say that part 2, new sum of x minus 45 is minus 164, and new sum of x minus 45 squared is 3089 plus 29 minus 45 squared. So I'm taking the x value and I'm squaring it, and then I'm adding it to the total. So that gives me 3345. Now my new n is 37. So I'm going to say that variance of x minus 45, that's what I'm trying to find. How would I find that? I would say that 3345 divided by 37 minus 164 over 37 squared. Right, I'm just taking a root of this so that I can find the standard deviation. 8.37. I'll have to check the numbers in this. Let's quickly open up the marking scheme. This is June 1162, question 3. Files. Have I calculated wrong then? 3345 divided by 37. Oh yeah, I calculated wrong. So 8.41 is the correct answer. Instead of doing 164, I've done 167. Yeah, that's what I was thinking. I've done it the correct way. You can also see in the marking scheme that there are two ways to do this question, whichever way you feel comfortable. I've done the first way for you. Then it says or here, and it goes on and calculates that. All those sum of x squares and everything, and then comes up with the final answer. Okay, moving on to question 9. The following histogram illustrates the distribution of time in minutes that some of the students spend taking a shower. Okay, so copy and complete the frequency table for the data. So from between 2 and 4, what is the frequency density? It's 10, so I'm going to write a 10 in the 10 here. Then I see that the frequency density is 22. Then I see that the frequency density is 34. Then I see that the frequency density is 30. Then I see that the frequency density is 15. And the last one is 6. I need the class widths. So 2, 2, 1, 1, 2, and 6. When I multiply frequency density with the class width, I get frequency. So 20, 44, 34, 30, 30, and 36. Yeah, we have the correct numbers. Okay. Then for mean, you need the midpoints. So the first midpoint is 3, the next midpoint is 5, the next midpoint is 6.5, 7.5, 9, and 13. And the frequencies are 20, 44, 34, 30, 30, and 36. So the mean is simple then. 3 into 20 plus 5 into 44 plus 6.5 into 34 plus 7.5 into 30 plus 9 into 30 plus 13 into 36 divided by, oh, how many people were there in total? No, I don't have that. I'll have to add all of them up. So 20 plus 44 plus 34 plus 30 plus 30 plus 36. That gives me 194, I think. So let's write this. 3 into 20 plus 5 into 44 plus 6.5 into 34 plus 7.5 into 30 plus 9 into 30 plus 13 into 36. You must be good with your calculators because this takes time, and there will be errors as you go on and do them. Okay, so I'm getting 7.55, and yes, that's the correct answer. Then says two of these students are chosen at random. Find the probability that exactly one takes between 7 and 10 minutes to take a shower. This is from probability. It's not from this chapter, but let's just quickly get done with that. Between 7 and 10 minutes to take a shower. So 7 and 10 minutes, how many people are we talking about? We're talking about 60 people. So the first person that you take is 60 over 194, and the next person that you then take is not from these people. So you'll say that how many were not taking more than between 7 and 10 minutes? There were 134, but since you've already chosen one, you will reduce the denominator. But inherently you've assumed that the first person is your successful person and the next person is your failure. In that case, you have to make sure that you repeat the order as well and switch around the numbers as we've done in lots of other questions in probability. That is what your answer should look like. Let's see if we get the correct answer. What's 60 into 134 divided by 194 into 193 and then multiplied by 2, 0.429. Let's look at the last question for this video. It says the times and minutes for 7 students to become proficient at a new computer game were measured. The results are shown below. Find the mean and standard deviation of these times. Okay, so 15 plus 10 plus 48 plus 10 plus 19 plus 14 plus 16 divided by 7. 86.7 standard deviation. It was 257 over 7, just to be precise. Okay, I think I've done some calculation mistake. 15, 10, 48, 10, 19, 14, and 16. It's 3542 over 7. Looks a little weird. Oh, this was wrong. It's 132/7. That was also wrong. 18.9. So 3542/7 minus 132/7 squared. Getting 150.4, and then you take a root and you get 12.3. It's a state which of the mean, median, or mode would you consider to be the most appropriate to use as a measure of central tendency to represent the data. There is a mode, but it's very unrepresentative because it's the lowest value. That's the mode. Um, when I talk about uh, the mean, you see there's an unusually large value, and which we'll later learn is called the outlier. Okay, so since there are outliers, the mean is distorted, so is the standard deviation. So the best thing to use in this case is median. This is coming up in the next chapter. It's a lot more, it's in a lot more detail with a lot more examples in the lecture, so you can watch that. So I'd use the median because it's not distorted by outliers. The mean is affected by outliers, and the mode is the smallest value. For each of the two measures of average you did not choose in part one, give a reason why you consider it inappropriate. That is what I already told you. I think I answered the third question in the second question only. You can read it out from here. The mode is 10 because it's inappropriate because it is the smallest. Part two says I'm just going to choose the median, and mean is inappropriate because it is affected by the outlier 48. So one person, took 48. So that's a problem. Okay, I will see you in with another video shortly with the next worksheet and with representation of data part 2. If you haven't subscribed, please make sure to subscribe and like and share this video with your friends. Thank you for watching.